Okay, guys, today inshallah we're gonna start in section 2, chapter 22. Last time we started section 1, which we started generally about the organic compounds, and we know that organic compounds, they are compounds that contain carbon element. That means all organic compounds contain carbon, but not all compounds that contain carbon classified as organic compounds. So we said that organic compounds, they just contain carbon and some other elements, mainly hydrogen, nitrogen, oxygen, sulfur, and phosphorus, and so on. So today in that section, on section 2, we're just going to talk specifically about the hydrocarbons. So what are the hydrocarbons? Hydrocarbons, simply, they are the simplest form of organic compounds ever, just made of two elements only, carbon as the main or the basic element in all organic compounds, and hydrogen. That's why we call them hydrocarbons, okay? So like this here, we said that hydrocarbon consider the basic or that the minimum level of organic compounds of complication. That means that the simplest form of an organic compound, just made of two elements, carbon and hydrogen. Whatever the number of the carbon and hydrogen is, we call this hydrocarbon. Actually, hydrocarbon considered as the basic structure in which the other organic compounds could be formed from hydrocarbon, or they consider to be as a kind of or they produced from the hydrocarbon by just removing one hydrogen or more and replacing them with one of the functional group or something like that. Actually, that's hard words to understand. So let's get an example to clarify the idea. So simply here, for example, when we just say this, okay, or just make it two carbon, that's enough, okay, to make it easier. So here, like this, these two carbons, actually, once they attach to a hydrogen like this, as we know last time, what make the carbon atom special, that is able to make four bonds and is able to attach to another carbon atom. So like this here, that's a simple representation for, okay, a hydrocarbon here. It's just made of carbon and hydrogen, C2H6, okay? So that is ethane. So here that is an organic compound and it's a hydrocarbon. So simply, if we just remove one of these H, okay, for example, we just remove this H and we add another functional group. For example, we are just gonna add a group of, let's make it, okay, a group of OH. So in that case, it will be alcohol, ethanol, okay, the alcohol which you use nowadays a lot. Okay, so that means, okay, if we just also remove these, okay, and we just add a new functional group like COOH, okay, so that will be here an acid, okay, so that will be propionic acid. So like this, okay, guys, we could find here just changing one hydrogen, okay, and replacing by different functional group, okay, or different functional groups, or maybe different element, like for example, if we remove these, okay, uh, here, like just we add, for example, PR, so that ethyl bromide, okay, and so on. So like these different organic compounds, they are already, okay, made of hydrocarbon by removing one H and replacing by another functional group. Is it clear here, guys? Guys, is it clear?
Yes.
Yeah. Okay. So like this, that the idea, or that represent that the hydrocarbons consider be the basic, okay, structure, or that's considered be the simplest form of organic compound. Actually, hydrocarbons could be classified into or two main categories. Okay, saturated hydrocarbons and unsaturated hydrocarbons. What the difference between them? Saturated hydrocarbons, they are the hydrocarbons in which all the carbons in these compounds are attached by single covalent bond, okay? Like this one, for example, here, just single covalent bond between the carbon. So we call this a saturated hydrocarbon. While the other one, they may contain one or more double or triple covalent bond between carbons. Let's get an example to understand here. Look with me here, guys. So we can say that hydrocarbons, they could be classified into two types, okay, as we said. So what are these two types? We said that it could be saturated hydrocarbons or unsaturated. What difference between saturated hydrocarbon and unsaturated hydrocarbon? So as we can see here, let's find. So saturated hydrocarbons, they are like whatever the number of carbon is, for example, 3, 4 carbons, okay, and they just carry the hydrogen as you can see here, okay. So of course we can, if we don't write the H, okay, or just it's just like a dash without something, it means it's hydrogen, as we said last session. So here we could find these 4 carbons, actually they just bonded together by a single covalent bond. Just single covalent bond attach each carbon to the next one. So like this, we call that it's saturated, okay. While the unsaturated, okay, for example, like here, sorry, okay. For example, here, once we have this, so as you can see here, not all the carbons are attached by single. Here we have a double covalent bond between the second and the third carbon atoms. Okay, so like this, it's unsaturated. And actually, the word unsaturated, it means that it doesn't completely fill. So what is not completely filled or doesn't have the maximum capacity? Because here it lacks for 2 hydrogen, as you could observe if we compare these 2 compounds together. So you could observe that here the second and the third carbon, they each one carry 2 hydrogens. But in that case, they just each one carry 1 hydrogen only. So that's why you put unsaturated, because it actually doesn't have the full capacity of hydrogen. So once we find there is a double bond, okay, or maybe a triple bond, like this example, okay. So in that case, you can find that second and the third carbon, for example, they are attached by triple bond here, triple covalent bond, so also considered to be unsaturated. So like this, the saturated, okay, the only example of saturated hydrocarbons, we call them alkane, or the group, okay, of hydrocarbons that are saturated, we call them alkanes, okay. While the one which contain double bond, we call them alkenes. Okay, while here the one which contain the 3, okay, bond, the 3 covalent bond or triple covalent bond, we call them alkynes. So that's the difference between them, okay? What difference between alkane, alkene, and alkynes? Okay, that alkane just contain 1 single covalent bond between the carbons. Alkyne contain at least 1 double bond between the carbon. Okay, alkyne they contain at least 1 triple bond between carbons. Is it clear here, guys? Guys, any hard question at that point? Guys,
Nice.
clear?
Yes. Yes.
Okay. So today, actually, guys, we're just gonna start with the first category, which is the saturated, okay, hydrocarbons or alkanes. So alkanes, or they are saturated hydrocarbons, as we can see here, okay, they just carbon, as we said, just 1 single bond between the carbons, okay, and they carry the full capacity of hydrogen. And just here, for example, we could find that ethane and propane, as you can see here, this one, okay, just contain 2 carbons. Each carbon carry 3 hydrogens. Then we pass to the next one, have 3 carbons. So if I just mention, if you could observe what the difference between these 2 compounds, guys, what the difference, what you could observe, what you could observe, guys. Anyone can tell me what the difference between propane and ethane, as you can see here?
Propane has 3 carbon.
Yeah, propane has 3 carbon, while ethane has
2.
this extra carbon carry how many oxygen? How many hydrogen? Sorry,
Extra 2.
extra 2 hydrogen. So that's mean here. So I'm gonna ask you, Hassan. Imagine if we need to make this propane, okay, butane. That means 4 carbons. What we're gonna do? Tell me.
If you're going to make what?
If we need to make this propane, butane. That means,
Yeah.
okay, 4 carbons instead of 3. So what we're gonna do?
We will add 1 carbon.
Yep. How? That means we need to remove
This
this H, okay, and this
Put here.
hydrogen, yes, and just we put
Put 1 H here and 1 H here.
and like this, yes or no?
1 down.
So
Yes.
like this, you're gonna find it means it was, if we compare this to the last one, it's still the same, but we just added 1 CH2. You get the idea?
Yes.
That the part which you added, okay, because it's already, it was ended by CH3 and now it ends by CH3. So what is added considered to be CH2? Yes.
CH2.
Guys.
Yes.
So that means in alkane, they all have the same structure, okay, and each alkane differ then to the next one by just one extra CH2. You get the idea?
Yes.
Yep. Okay. So that's why we call all the alkanes, okay, to be homologous series. So what I mean by homologous series, that means they are a series of compounds that have adjacent number but different that differ in constant unit, which is CH2. That means the difference between each alkane and the next, just one extra carbon with two hydrogens. Is it hard like this? Any hard question here, guys? Guys, any hard question?
Yes.
So imagine if we need to make it 5, just so if we need to make it 5, we are just gonna remove this H, okay, and make it like that. Yes or no? So in that case, that will be considered the addition here. Yes or no? You get idea?
Yes, sir.
So and keep so on. So like this, we said that all hydrocarbons, they could follow a general formula, which is CnH2n plus 2. That the general formula which represent the number of carbon related to the number of hydrogen in alkanes or saturated hydrocarbons. That means any alkane follow this number. So for example, if we said if we have alkane that contain 5 carbons, how many hydrogen will be carried by these 5 carbons? So let's follow this equation as 5. So that means C5 H2n. So 2, that means 2 multiply 5 plus 2. So it will be 12. That means we're gonna find there are 12 atoms, okay, or 12 hydrogens are carried on 5 oxygen. Let's check here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You get idea, guys?
Yes, Mister.
Yep. Okay. So like this, okay, any kind or just any hydrocarbon consider or especially alkane could say it's a homologous series because they follow a general formula, and also okay that means each compound differ than the next by a constant value, which is CH2. So then pass to the next point here, guys. Okay, as you can see here, for example, that's the methane, okay, CH4, just one carbon with 4 hydrogen, okay, C2H6 ethane, 2 carbons with 6 hydrogen, and so on. But here, look to me, butane, C4H10, okay, so there are 4 carbons carrying 10 hydrogens. So guys, what the difference between these two? Anyone can tell me? Or what we call these two regarding to what we studied last section? Do you remember? Two, okay, chemical compounds have the same atomic number, or sorry, have the same number of atoms but in different arrangement. So we call them, anyone remember? 2 bonus marks for the one who are gonna answer the question.
Isotope.
No, you just close but not enough. Okay, we call them isomers. We call them isomers. Okay, isotopes actually are different forms of the same element, not compound. Okay, same element, okay, they have the same
Yes.
atomic number but different mass number, but here it's completely different. Here we have 2 compounds, okay, these 2 compounds, they have the same number of atoms, both contain 4 carbons and both contain 10 hydrogens, but they have different arrangement, okay, in space. So if they have this different arrangement, they are completely different elements with different physical and chemical properties, so we call them isomers. So as you can see here for alkanes, okay, alkanes with carbons less than 3 or 3 and fewer, okay, they cannot have isomers because you just has only one possible arrangement or one possible orientation in space, so never they have isomers. For example, propane, just 3 carbons, so there is no chance, okay, to make them in different arrangement, just one arrangement, so there is no isomers for propane or ethane or methane. But starting from 4 carbons and more, okay, that means 4, 5, 6, whatever, okay, we are gonna have different number of isomers. For example, butane here have 2 isomers, okay, and as the number of carbon increases, the alternatives or the isomers increases also, and they increase dramatically. For example, here you could find that if we have 5 carbon, okay, that here, for example, for pentane, the C5H12, they are gonna have about 3 isomers, while C6H14, okay, they have 5 isomers, okay, but here C7H16 they have about 9 isomers. So although it's just one carbon extra, make the number of isomers somehow doubled. You get the idea? You get this, guys? Imagine that if we have 25 carbon, that means alkane that contain 25 carbon, it will have 37 million possible isomers. You got this, guys? Do you imagine how the change in number or the increase in the number of the carbons make the possibility of isomers, okay, increases? Do you get this, guys?
Yes.
Is it clear?
Yes.
Okay, so like here, guys, so what we know till now that alkanes is known as saturated, okay, hydrocarbons, and we know that all the carbons are attached to each other by single covalent bond, and they carry maximum capacity of hydrogen. They follow the same, okay, general formula, which is CnH2n plus 2. Okay, and we said that the smaller hydrocarbons, that means just contain 1, 2, or 3 carbons, they do not have isomers, while more than 4 or 4 and more, they have different isomers. And as the number of carbon increases, okay, of course, the number of isomers increase. So actually, not all hydrocarbons or not all alkanes, they just found in form of chains or just straight or branched chain, okay, of carbon like this. Sometimes they are found in form of rings or cycles, okay, so that's why we call them cycloalkane. So cycloalkanes, they just alkanes that carbons are attached to each other to form a ring, okay, whatever how many sides in that ring or how many sides in this cycle, okay. So that depends on the number of the carbons. So for example, here we have 5 carbons, okay, so they attach to each other, so they make like a pentagon, okay, so that's what we call this cyclopentane, okay. So 5 sides, okay, because of 5 carbon, each carbon represents an angle of this pentagon, okay. So if they are more, for example, they are 6, so they are gonna make a hexagon shape. If they are 7, they make a heptagon shape, and so on. So like this here, we said that the cycloalkane, they just alkanes that are found in form. Once we try to draw them, we can write them here like in full details like that, okay. That means we represent each carbon at one angle of the cycloalkane, and then each carbon will be carried by 2, or will carry 2 hydrogen because it's already bonded by 2 bonds to the next carbons in the 2 sides. Or we can just make it as a simple here, like a pentagon shape that represents the skeleton of the formula. So like this, once we draw a pentagon, okay, like this, we know that is a cyclopentane because it's just each angle represents 1 carbon atom with 2 hydrogens. Is it clear here, guys? Guys, is it clear?
Yes.
Okay, but you could observe something important here. What is here? Okay, let's try to do it. Okay, if we said that the normal pentane or the normal alkane that contain 5 carbon, let's try to draw it together. So if we have, for example, this 1, 2, 3, 4, 5, then we're gonna make a full capacity of hydrogen. So just put hydrogen above the carbon. So like this. How many carbon, how many hydrogen in this one, guys? How many hydrogen in the pentane? Guys, how many hydrogen here? Grade 11, can you hear me?
15.
How 15? Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just 12. So we have 12 hydrogen here. You got the idea?
Yes.
So once it's just like a straight chain, or it's not cyclic alkane, so you could find that here we have 12 carbon, but once they are found in cyclic form, or that is cyclopentane, let's count how many hydrogen here. How many, Tadros?
2, 4, 6, 8, 10.
10. So that means the number of hydrogen in case of cyclic alkanes are less than the number of hydrogen in the straight one. Yes?
Yes.
Yes, it's always less by 2. Why? Because actually the 2 hydrogen which are found on the edges here, okay, they are removed to make these 2 carbons bonded to each other to make the cycle. Good idea?
Yes,
So
sir.
these two hydrogen must be removed. So always we're gonna find that the normal alkane is less by 2 hydrogen than the cyclic one. A good idea?
Yes.
Is it clear, guys?
Yes.
Yep. Okay, so here like this, that's something also we need to know, that the number of hydrogen. So although here the number of hydrogen is less than the straight alkane, but still saturated because the carbons are attached to each other by single covalent bond, and they carry the maximum capacity of hydrogen that they could carry to form this arrangement in space. Okay, guys? Is it clear?
Yes.
Yep. Now let's pass to the most important part here, how we could name alkanes. Now we say propane, ethane, methane, and so on. So how could I know these names, or how we memorize? Actually, don't memorize these names because we have infinity of alkanes or infinity of organic compounds. So it's hardly to memorize their name, but we have a technique or a way to name them. Okay, so we have a system to name alkane. So to be able to name the alkane, you must memorize the prefixes, okay, the Latin prefixes which reflect the different numbers. So number 1 means meth, 2 eth, 3 prop, 4 put, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. Okay, so these represent the numbers in Latin, guys. Okay, so we supposed to memorize them. That's for must, of course. Okay, so let's find here what we are gonna do, or what we're just. So for example, if you have just unbranched the chain of alkane, there's one straight chain like this one. All what you're gonna do is just counting the number of the carbons. How many carbons? For example, here 1, 2, 3, 4, 5, 6, 7 carbons. So what the number of 7? It's hept. So we're gonna say hept and add the prefix and. So we gonna say it's heptane, and it represents alkane. So that means it's a chain made of 7 carbons. All the bonds between their carbon are single covalent bond because it's an. You get this, guys? Is it clear?
Yes.
So who can name this to me? Okay, let's try. Okay, so who can name this one? Okay, who can name this one, guys?
Butane.
I can't hear you.
Butane.
Not butane. Okay,
Put.
so this not put. Okay, so butane. Here, guys, that's good. So simply 4 carbons, so it's but, and because they have just one single covalent bond between them, so we add the 4 and so it's butane. Is it hard like this? Any hard question here, guys?
No.
No. So let's pass to the next. So here like this, you could see here, this paper presents you the idea. So 1 carbon is methane, okay, 2 carbon is ethane, 3 carbons propane, 4 carbons butane, as Tedros said, 5 carbon pentane, and so on. Okay, so we have something called the alkyl group. What is the alkyl group? Alkyl group, actually it's represent the same alkane, but if we just remove one hydrogen, for example CH4, it's methane. If we just remove one hydrogen to be CH3 and the carbon still miss one bond or still need to bond with something, okay, we call it methyl group. Okay, so that's alkyl. We use the same prefix but adding the prefix "-yl". So methyl, ethyl, propyl, butyl, pentyl, and so on. You got this, guys? You got this?
اه تمام.
Okay, so here the alkyl group, okay, or in some actually to know because in SAT exams or something like this, okay, so they always use this, okay, or just here they give it a letter R, okay, so R actually means the alkyl group, whatever this group is, okay, methyl, propyl, ethyl, blah 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 blah. So R, it means an alkane with missed hydrogen, okay, or missed, okay, bond. So here like this, that's the simplest way to name the alkanes, or just to name the hydrocarbon alkanes, okay, because simply we count the number, okay, and then we mention the prefix of the number and then the suffix of "an", so that's the name. That in case if we just have one single, okay, or one straight branch, okay, as we said in the previous example. But what would happen if we have someone which is not straight branch like this one? How we could name this one? Okay, that's actually is very, very important to know, guys. So how we could mention, let's find what are the steps, okay, to be clear for you. Okay, so first of all, you must find the longest chain ever. Okay, so whatever this chain is, straight or even curved, we don't care, but we need to find the longest chain of carbon. So who can find the longest chain of carbon, guys? Okay, so let's count. If we just look at this one, 1 2 3 4 5 6 7. Okay, sorry, 1 2 3 4 5 6 7 8. That the 8 carbons, yes or no? You get this?
Yes.
Yeah, or if we count like this, 1 2 3 4 5 6 7 8, also that's 8. Okay, or 1 2 3 4 5 6 7 8. So whatever the maximum number that, or the longest chain I could have ever is 8. So for example, we're gonna just say like this. Let's count here, 1 2 3 4 5 6 7 8. They are 8 carbons. So that is the maximum, yes or no? Is it or not? Can be that,
Yes.
can this be considered the longest chain?
Yes.
Okay, so that's considered to be the longest chain. So actually that is not the longest one, or that's not the best chain to choose ever. Why that's not the best chain to choose ever? Okay, because actually here you're gonna find that in this carbon you're gonna find there are two attached in this, so we need to have attachments, or that means the branches to be in separate carbons. So that means here, and for example, that is if we count from this side, so that is the third carbon. The third carbon carry here different, okay, or they carry different, okay, two attachments. This is ethyl group and that is methyl group, so that will not work properly. So we need to have them in separate ways. So look with me carefully. If we just choose this branch like that, that's also 8 carbons, but here we're gonna find that CH3 is attached on the second carbon, while here the CH2 is attached on the third carbon. You get the idea, guys? Is it clear?
Yes.
Yep. So here, as you can see, this part is very important. So the first step, we must choose the longest, okay, or the long, okay, chain of atoms or chain of carbon. That the longest one, 8-1, okay. And why that specially? That's to ensure that each branch is found on a separate carbon, okay. You get the idea? Okay.
تاني كانسر.
Again, here we choose this one. How many they are? They are 8. And also if we choose this one, let's make it in another color. That's in yellow. This is chain also the, sorry, this is chain also is 8 carbon, yes or no? Yes. Yes, Yahya.
اه
Both of them are 8. So why we choose the red one, not the yellow one? Because actually the yellow one you're gonna find in third carbon, they has 2 attachment. That means this is attached to this and this attached to this, okay. You get idea?
اه تمام.
But in this one, the red one, this CH3 is attached to second carbon, while CH2, CH3 is attached to the third carbon. So they are 2 branches and 2 different or 2 separate carbons. You get the idea?
Yes, yes.
Yep. Okay. So that would be per. Okay, that's it will be used. So we are gonna just use this one, or we're gonna try to get this one. Is her like this? Okay. In her question till that moment, guys. In her question.
Yes.
So like this, that is the basic chain which we're gonna work on. So how many carbon in this chain, guys? Guys, how many carbons is that chain?
8.
8. So what we call it? 8 means oct. So it will be octane. Yes or no?
Yes.
So that's the basic, but actually that represent the entire compound or just represent this chain?
لا this chain.
This chain. So that is not the full name because there are extra additives or there are some branches on the main chain. So we need to mention the location and the name of these branches. Okay. So what are the branches which are found? Let's find here. What are the branches? We have CH3, C2CH3, another CH3, and another CH3. So let's find CH3. What the name of the CH3 group? Okay, one carbon. So we call it methyl. Okay. Why aryl? Because it's CH3, not CH4. That means it's alkane with missed one, so it's an alkyl group. So its name is methyl. Okay, guys? Okay? Like here in the table. Okay? This one, CH3, methyl. Okay? Then here we back to the point. This C2H3, that's ethyl. Okay, so this is ethyl. So we have ethyl and the 3-methyl, 1-ethyl and 3-methyl branches, okay, attached to this. So we need to find which one I should mention first, the methyl or ethyl. Actually, we mentioned in alphabetic order. So E is before M. So we're gonna say we are gonna mention the ethyl first. So ethyl found in which carbon? Ethyl found in that carbon. So once we try to count this chain, we're going to count from this side or that side. Actually, we are going to count from the nearest carbon to the branch. So this branch found here, so that would be the third. But if we count here, it will be the fifth. So it's better to count, or the sixth. So it's better to count from here. So like this, we're going to count 1, 2, 3, 4, 5, 6, 7, 8. So like this ethyl group found on the third carbon. So we're gonna see 3 ethyl. Then, okay, we're gonna find that we have methyl group in carbon number 2 and another ethyl group in carbon number 4 and another group and another ethyl group, in carbon number 5. So we are gonna say 2, 4, 5. Okay, try that means 3. Okay, ethyl group, which means we have 3 ethyl groups on carbon number 2, 4, and 5, and then we mention the name of the longest chain octet. You get this, guys? Did you get this, guys? Is it hard like this? So that's how we name. So like this, once we look at this formula and we ask what the name, you're gonna say the name of this compound is 3-ethyl-2,4,5 trimethyl. So that's methyl, not ethyl. Trimethyl octane. Is it clear here, guys? So actually, next time we're gonna practice more about naming them. But what I need you to do, that's very, very important. You must do it today to be able to practice tomorrow, inshallah. You must memorize the Latin names, okay, just from 1 to 10 in Latin, okay, meth, eth, prop, and so on, okay, and know the difference between the alkane, okay, and the alkyne. So just memorize this table, okay, the idea of this table, and memorize the table of the numbers. And tomorrow, inshallah, we're gonna practice more about naming the alkane. Any hard question of today's session, guys? Do you want to ask any question before we end our meeting?
Thank you, Mr.
Okay, guys. So please study this part very well from your textbook, and we're gonna just meet tomorrow to make more practice about naming the alkanes and continue our section. Thank you, guys, and goodbye.